Chapter 12 of How It Flies, or Conquest of the Air. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. How It Flies, or Conquest of the Air, by Richard Ferris. Chapter 12. The Glider. It is a matter of record that the Wright brothers spent the better part of 3 years among the sand dunes of the North Carolina sea coast, practicing with gliders. In this way they acquired that confidence while in the air which comes from intimate acquaintance with its peculiarities, and which cannot be gained in any other way. It is true that the Wrights were then developing not only themselves, but also their gliders. But the latter work was done once for all. To develop aviators, however, means the repeating of the same process for each individual, just as each for himself must be taught to read. And the glider is the first reader in aeronautics. The long trail of wrecks of costly aeroplanes marking the progress in the art of flying marks also the lack of preparatory training, which their owners either thought unnecessary or hoped to escape by some royal road less wearisome than persistent personal practice. But they all paid dearly to discover that there is no royal road. Practice, and still more practice. That is the secret of successful aeroplane flight. For this purpose, the glider is much superior to the power-driven aeroplane. There are no controls to learn, no mechanism to manipulate. One simply launches into the air and concentrates his efforts upon balancing himself and the apparatus, not as two distinct bodies, however, but as a united whole. When practice has made perfect the ability to balance the glider instinctively, 9/10 of the art of flying an aeroplane has been achieved. Not only this, but a new sport has been laid under contribution, one beside which coasting upon a snow-clad hillside is a crude form of enjoyment. Fortunately for the multitude, a glider is easily made, and its cost is even less than that of a bicycle. A modest degree of skill, with a few carpenter's tools, and a little gumption about odd jobs in general, is all that is required of the glider builder. The frame of the glider is of wood, and spruce is recommended, as it is stronger and tougher for its weight than other woods. It should be of straight grain and free from knots, and as there is considerable difference in the weight of spruce from other trees, it is well to go over the pile in the lumber yard and pick out the lightest boards. Have them planed down smooth on both sides, and to the required thickness, at the mill. It will save much toilsome handwork. The separate parts may also be sawed out at the mill, if one desires to avoid this labour. The lumber needed is as follows: 4 spars 20 feet long, 1 1/4 inches wide, 3/4 inches thick. 12 struts 3 feet long, 1 1/4 inches wide, 3/4 inch thick. 2 rudder bars 8 feet long, 3/4 inch wide, 1/2 inch thick. 12 posts 4 feet long, 1 1/2 inch wide, 1/2 inch thick. 41 ribs 4 feet long, 1/2 inch wide, 1/2 inch thick. 2 armrests 4 feet long, 2 inches wide, 1 inch thick. For rudder frame, 24 running feet, 1 inch wide, 1 inch thick. If it be impossible to find clear spruce lumber 20 feet in length, the spars may be built up by splicing 2 10-foot sticks together. For this purpose, the splicing stick should be as heavy as the single spar, 1 1/4 inches wide and 3/4 inches thick, and at least 4 feet long, to be bolted fast to the spar with 6 1/8 inch round head carriage bolts, with washers of large bearing surface, that is, a small hole to fit the bolt, and a large outer diameter, at both ends of the bolt, to prevent crushing the wood. A layer of liquid glue brushed between will help to make the joint firmer. Wherever a bolt is put in, a hole should be bored for it with a bit of such size as the bolt will fit snug in the hole without straining the grain of the wood. The corners of the finished spar are to be rounded off on a large curvature. The ends of the struts are to be cut down on a slight slant of about 1/16 of an inch in the 1 1/4 inches that it laps under the spar, with the idea of tipping the top of the spar forward so that the ribs will spring naturally from it into the proper curve. The ribs should be bent by steaming, and allowed to dry and set in a form, or between blocks nailed upon the floor to a line of the correct curve. They are then nailed to the frames, the front end first, 21 to the frame of the upper plane and 20 to that of the lower plane, omitting one at the centre where the arm pieces will be placed. Some builders tack the ribs lightly into place with small brads, and screw clamps formed from sheet brass or aluminium over them. Others use copper nails and clinch them over washers on the underside. Both methods are shown in the plans, but the clamps are recommended as giving greater stiffness, an essential feature. At the front edge of the frames the ribs are fastened flush, and being 4 feet long and the frame but 3 feet wide, they project over the rear about 1 foot. The arm pieces are bolted to the spars of the lower frame 6½ inches on each side of the centre, so as to allow a free space of 13 inches between them. This opening may be made wider to accommodate a stouter person. The posts are then put into place and bolted to the struts and the spars as shown, with 1/8 inch bolts. The entire structure is then to be braced diagonally with No. 16 piano wire. The greatest care must be taken to have these diagonals pull just taut, so that they shall not warp the lines of the frames out of true. A crooked frame will not fly straight, and is a source of danger when making a landing. The frames are now to be covered. There is a special balloon cloth made which is best for the purpose, but if that cannot be procured, strong cambric muslin will answer. 30 yards of goods 1 yard wide will be required for the planes and the rudder. From the piece cut off 7 lengths for each plane, 4 feet 6 inches long. These are to be sewed together, selvage to selvage, so as to make a sheet about 19 feet 6 inches long and 4 feet 6 inches wide. As this is to be tacked to the frame, the edges must be double hemmed to make them strong enough to resist tearing out at the tacks. 1/2 inch is first folded down all around. The fold is then turned back on the goods, 2½ inches, and sewed. This hem is then folded back 1 inch upon itself and again stitched. Strips 3 inches wide and a little over 4 feet long are folded 3 double into a width of 1 inch, and sewed along both edges to the large sheet exactly over where the ribs come. These are to strengthen the fabric where the ribs press against it. 16-ounce tacks are used, being driven through a felt washer the size of a gun wad at intervals of 4 inches. If felt is not readily obtainable, common felt gun wads will do. The tacking is best begun at the middle of the frame, having folded the cloth there to get the centre. Then stretch smoothly out to the 4 corners and tack at each. It may then be necessary to loosen the 2 centre tacks and place them over again to get rid of wrinkles. The next tacks to drive are the ends of the struts, then halfway between, and so on, until all are in, and the sheet is taut and smooth. For a finer finish, brass roundhead upholsterer's nails may be used. The rudder, so called, is rather a tail, for it is not movable and does not steer the glider. It does steady the machine, however, and is very important in preserving the equilibrium when in flight. It is formed of 2 small planes intersecting each other at right angles and covered on both sides with the cloth. The sections covering the vertical part being cut along the centre and hemmed onto the upper and lower faces of the horizontal part. The frame for the vertical part is fastened to the 2 rudder bars which stretch out toward the rear, one from the upper plane and the other from the lower. The whole construction is steadied by guys of the piano wire. To make a glide, the machine is taken to an elevated point on a slope, not far up to begin with. Lift the glider, get in between the arm rests, and raise the apparatus until the rests are snug under the arms. Run swiftly for a few yards and leap into the air, holding the front of the planes slightly elevated. If the weight of the body is in the right position, and the speed sufficient, the glider will take the air and sail with you down the slope. It may be necessary at first to have the help of 2 assistants, one at each end, to run with the glider for a good start. The position of the body on the arm rest can best be learned by a few experiments. No 2 gliders are quite alike in this respect, and no rule can be given. As to the requisite speed, it must be between 15 and 20 miles an hour, and as this speed is impossible to a man running, it is gained by gliding against the wind, and thus adding the speed of the wind to the speed of the runner. The Wrights selected the sand dunes of the North Carolina coast for their glider experiments because of the steady winds that blow in from the ocean across the land. These winds gave them the necessary speed of air upon which to sail their gliders. The first flights attempted should be short, and as experience is gained, longer ones may be essayed. Balancing the glider from side to side is accomplished by swaying the lower part of the body like a pendulum, the weight to go toward the side which has risen. Swinging the body forward on the arm rests will cause the machine to dip the planes and glide more swiftly down the incline. Holding the weight of the body back in the arm rests will cause the machine to fly on a higher path and at a lower speed. This is objectionable because the glider is more manageable at a higher speed and therefore safer. The tendency at first is to place the weight too far back, with a consequent loss of velocity, and with that a proportionate loss of control. The proper position of the body is slightly forward of the mechanical structure of the machine. The landing is accomplished by shoving the body backward, thus tilting up the front of the plane. This checks the speed, and when the feet touch the ground, a little run, while holding back, will bring the glide to an end. Landing should be practised often with the brief glides until skill is gained, for it is the most difficult operation in gliding. After one becomes expert, longer flights may be secured by going for higher points for a start. From an elevation of 300 feet, a glide of 1,200 feet is possible. While it is necessary to make glides against the wind, it is not wise to attempt flights when the wind blows harder than 10 miles an hour. While the flight may be successful, the landing may be disastrous. The accomplished glider operator is in line for the aeroplane, and it is safe to say that he will not be long without one. The skillful and practised operator of a glider makes the very best aeroplane pilot. This chapter would not be complete without an adequate reference to the gliders devised by Professor Montgomery of Santa Clara, California. These machines were sent up with ordinary hot air balloons to various heights, reaching 4,000 feet in some instances, when they were cut loose and allowed to descend in a long glide, guided by their pilots. The time of the descent from the highest altitude was 20 minutes, during which the glider travelled about 8 miles. The landing was made accurately upon a designated spot, and so gently that there was no perceptible jar. 2 of the pilots turned completely over sideways, the machines righting itself after the somersault and continuing its regular course. Professor Montgomery has made the assertion that he can fasten a bag of sand weighing 150 pounds in the driver's seat of his glider and send it up tied upside down under a balloon, and that after being cut loose the machine will right itself and come safely to the ground without any steering. Lilienthal in Germany, Pilcher in England, and Chanute in the United States are names eminent in connection with the experiments with gliders, which have been productive of discoveries of the greatest importance to the progress of aviation. The illustration of the Chanute glider shows its peculiarities plainly enough to enable anyone to comprehend them. The establishment of glider clubs in several parts of the country has created a demand for ready-made machines, so that an enthusiast who does not wish to build his own machine may purchase it ready-made. End of chapter 12.